Binomial radical expressions. So the first thing we do here is very familiar. This is like radicals. Think of it as like terms when you're adding variables. Like radicals have the same thing inside the radical and they have the same index. So if it has the same number or variable inside the radical and the same index on the radical, you can combine them, meaning you can add or subtract the numbers on the outside of the radical. When you add like radicals, what is inside does not change, just like the variables don't. All right, so for this first one, add or subtract if possible. The first thing you check is, what is inside? X and X, that is the same. Yes. Index, 3 and 3, that is the same. That means we can add or subtract the coefficients, so to speak. So I can say 5 minus 3. So my answer here would be 2 cubed root of X. 2 cubed root of X. And I can add and subtract those. That is my answer. For this next one, what is inside? So my index is the same. It's actually 2, even though I can't see it there. But if I look, what's inside is 2 and 3. I cannot add those. My answer here is just going to be 4. I can write here. 4 square root of 2 plus 5 square root of 3. That is my answer. I cannot combine that. It's like X plus Y. All right, like radicals. Very simple. So go ahead and try it. Check understanding number 1. Combine if possible. So if I look at the first one, I have 7s on the inside, yes. And I have indexes of 2, yes. So I can combine the 2 and the 3. 2 plus 3 is 5, so I have 5 squared is 7. For this one, my 5s are the same, but I have a 4 and a 3. My indexes are not the same, so I cannot combine those. That is my answer. For this last one, x and y on the inside, x and y on the inside. Index of 2, so I can add my 4 and 5, giving me 9xy. All right, so this one, you'll notice those are not alike. However, they're also not simplified, all right? So I do have radicals that have the same index, 2, 2, and 2, but on the inside I have 18, 8, and 72. However, 18, 8, and 72 can be simplified, all right? They don't have a perfect root, but I can simplify them somewhat. And so I'm going to simplify them. I'm going to take that 18 and I am going to simplify it, all right? If I'm looking for something that groups with 2s, then my 3 can come out, my 2 will stay in. And I always multiply it by that 6. So my 6 times the 3 that came out, and my 2 will stay in. For my 8, I have 2 and 4, 2 and 2. I have a group of 2s that can come out, and a 4 that is out. So I have 4 times 2 on the outside, and I have a 2 that will stay in, 2 on the inside. For the last one, 2 and 36, 2 and 18, 2 and 9, 2 and, 3 and 3, right? I have a 3 that'll come out, a 2 that will come out, and a 2 that will stay in. I also have a negative 3 that is on the outside here. So minus, and it's in my way, so 3 times the 2 that came out times the 3 that came out, and then a 2 that stays in. So if I simplify these, I have 18 square root of 2 plus 8 square root of 2 minus 18 square root of 2. All right, so I have all of these. And now I can combine it. I can say I have now the same number on the inside and the same index, so those can be combined. So I can say 18 plus 8 minus 18 is going to give me 8 square root of 2. So just walk through this. For the 50, 2 and 25 and 5 and 5. So 5 came out and 2 stayed in, and there was just a 1 on the outside, so it's 5 squared of 2. For 32, 2 and 16, 2 and 8, 2 and 4, 2 and 2. If you saw that 16 here was a root, you could just take out the 4. But if not, group of 2 came out, group of 2 came out, so you have 3 already on the outside, so you have 3 times 2 that came out, and a 2 that stayed in, so you have 12 squared root of 2 for this one. This last one, 2 and 9, 3 and 3, my 3 grouped up and came out, multiplied by my 5, gave me the 15, it is subtraction, and my 2 stayed in. So since they are all now alike, I can say the 5 plus the 12 minus the 15, all times the square root of 2, which gives me the answer of 2 square root of 2. All right, so multiplication is just exactly what you would do if this was variables. You're going to FOIL, and then you're going to apply your multiplication rules for your radicals. So for this, I would say 3 times 2, and 3 times 4 square root of 5. And then I would say 2 square root of 5 times the 2 plus 2 square root of 5 times 4 square root of 5. All right. And then I'm going to simplify these. So, of course, my 3 and 2 is 6. When I multiply a number and something like this, I just multiply the outside ones, the 3 and the 4. It's going to be 12 square root of 5. So same thing here. 2 times this group is just multiply the outside numbers. 2 and 2 is 4 square root of 5. For this last one, 2 times 4 is going to give me 8. Square root of 5 times square root of 5 is going to give me the square root of 25. Anytime you multiply a root by itself, it just ends up being the number inside the root. The square root of 25 is just 5. So you have 8 times 5. So anytime I multiply a root times itself, I get what's inside. So when I multiply this, I get the 2 and the 4, 8 times the 5. So that's going to give me 40. And then I'm going to simplify by combining my like terms, my like numbers, my like variables, my like radicals. So I'm going to take the 6 and the 40 and add those. These are like terms, so I can add the 12 and the 4 to give me 16 square root of 5. So go ahead and try check understanding number 4. So I have a 1 here, and a 1 here. So I have -1 minus 1, which gives me the -2. No, it's like saying -1x minus 1x. That would be -2x. You don't do anything with the x. All right, so multiplying conjugates. The term conjugate is the same exact binomial, except you change the sign of the last term. All right? So these are conjugates. I have a 2 and a 2. Yes, square root of 3 and square root of 3. The only difference between these is the sign in between them. All right? Not the sign at the beginning. That does not change. Only the sign in between them changes. This is a plus b, a minus b. You remember your special cases. A plus b times a minus b equals a squared minus b squared. Your middle term cancels when you have conjugates multiplied by each other. So we can FOIL it out and we can look at it, and then we'll do it the other way. So if we FOIL this thing out, we would say 2 times 2, right? 2 times negative square root of 3, positive square root of 3 times 2, and square root of 3 times the square root of 3. All right, so that gives me 4. And then I have minus 2 plus 2. Those are going to cancel. And then square root of 3 times square root of 3 is just 3. And that gives me 1. All right. Now, the shortcut here is to go straight to the square. All right. So if I were to go straight to squaring the first and subtracting the square, I'm going to just square this guy. So it would be 2 squared minus the second one squared. Square root of 3 squared. All right. This one is just 4. When I square a square root, I just get what is inside. All right, so that is multiplying conjugates. When you multiply conjugates, you square the first one, subtract, square the second one, and that is your answer. So go ahead and try check understanding number 5. So it's technically is dividing because you have a division sign there. Basically what you're doing is you are rationalizing the denominator. That's what this term is called. We did it when we just had a root on the bottom. So like if you have 5 over the square root of 2, right? For rationalizing that type of denominator, we would just multiply the top and the bottom by the square root of 2, right? Rationalize that denominator, make it a rational number, all right? In this case, we are going to multiply by the conjugate of the denominator. We are trying to get the root out of the denominator. So we are going to take this and we are going to multiply it by the conjugate of the denominator. So the conjugate of this denominator is going to be the exact 2 terms, but I am going to change the sign in between them. All right? And I am going to do that to the top and to the bottom. Whatever you do to the bottom of a fraction, you have to do to the top or you will change the fraction. All right? So I'm going to literally multiply the top and the bottom by the conjugate of the denominator. All right? On top, I have to FOIL. So I'm going to say 3 times 1. That gives me 3. 3 times the square root of 5. That gives me 3 square root of 5. 1 times the square root of 5. 1 square root of 5. And then I have the square root of 5 times the square root of 5. That's just 5. In the denominator, I am multiplying conjugates. I just did this. So all I have to do is square the first one. So that's 1 squared. Subtract and square the second one. Square root of 5 squared. All right? So I'm going to simplify. On the top, I'm going to combine my like terms. All right? My 3 and my 5 are alike, so that gives me 8. And then my 3 square root of 5 and 1 square root of 5 are like terms, so that's going to give me 4 square root of 5. On the bottom, I'm just going to simplify 1 minus Square root of 5 squared is just 5. 1 minus 5 is negative 4. All right? Now, the way you simplify this is you're going to divide it up so that you don't simplify incorrectly. So I'm going to rewrite this as 8 over negative 4 plus 4 square root of 5 over negative 4. And I'm going to simplify those individually. All right? So to simplify this, what's 8 divided by negative 4? That's just negative 2. 4 divided by negative 4. Only the outside number do you divide here. So I have negative 1 square root of 5. So I have negative 2 minus the square root of 5 as my final answer there. Rationalizing the denominator. Go ahead and try the middle of page 376. Check understanding number 6.